Hi there, this is Brad. I'd like to just do a playthrough of this applet for understanding div and mod. Part 1 deals with both div and mod. So this applet has a few parts for you to play with. In particular, we've got these two input boxes. The value for a could be any integer. The value for m can be any positive integer. And it says we can also pan, zoom, and move red things. So let's see, we can scoot things around like this. Uh, Whatever your zoom gesture is, you might be able to zoom out like this or zoom in. Oh, you can also reset the view. For this particular activity, a special kind of zoom is kind of nice. So if you hold down the Shift key and try zooming just the x-axis, this lets us do a horizontal zoom without affecting the vertical spacing of things. So that's a really good way to zoom for this activity. So let's see what we're supposed to do.
In the number line applet above, look and play in order to decide how the following things are related. First, try to relate 1 to 2, then 2 to 3, and so on, yada yada.
Okay, great. So first I'm going to connect 1 and 2. 1 is the values of a and m in the input boxes. Those are independent from each other, but they're connected to the later things. Number 2 here is the green dots shown on the number line and the numbers above and below them. So let's see. A equals 16. I can see there's a 16 over here, and the number 16 is circled, but that's not one of the green dots. Looks to me like the green dots are every fifth one. I could see 5, 10, 15, 20. We're counting by fives if we look at the numbers underneath. Or if we want to see explicitly how they are multiples of 5, 5 is 1 times 5, 10 is 2 times 5, and so on. What do you suppose will be the next green dot off the right side of the screen? Well, let's see. I would guess 5, 10, 15, 20, probably the next one is going to be 25, which is 5 times 5. And there it is. And so we can continue going if we like. 6 times 5 is 30, and so forth. So currently the green dots are counting by fives, which are the value of m. If I change the value of m, let's go to 6. Now the green dots are counting by sixes. 0 is no sixes, 1 copy of 6, 2 copies of 6, and so forth. You can use other values of m if you like. Here, let's count by 13s, starting at 0. 1 13 is 13, 2 13s are 26, and so on. The zone number. Okay, I'm going to want a smaller modulus, or I could zoom out, I suppose. If I use a smaller modulus, we'll be able to see more zones. So let's bring the modulus down to, let's say 8. 16 is exactly 2 times 8. So I can move this red point around, and the zone keeps track of where that red point is. Well, let's see, zone 1 has 1 times 8 in it. Zone 0 has 0 times 8. There's zone -1, and so on. The red circle indicates the number a. A is 14, the red circle's on 14. If I change the value of a to, let's say, 5, then the red circle moves to 5. Or if I move the red circle, it updates a. Okay, so that's a pretty strong connection there between the red circle and a itself. The equation above all of this stuff is using the modulus m to identify a structure within the number a. So in this case, a is 9. I can think of 9 as being some number of 8s plus a little bit. How many 8s? Well, that's 9 div 8. Well, if we move to different, there we go. Now div and mod give us different numbers. So the 1, 10 div 8 equals 1. This 1 is telling us that there's 1 whole 8 in 10. Here's 1 whole 8. It's 1 times 8. And then there's an excess of 2. So the number 10 can be broken up as 1 whole 8 and 2. 6 can be broken up as no 8s and 6. What about something like -2? -2, according to this way of thinking at least, is considered -1 copies of 8 and then 6 more. So it's less than no 8s. No 8s could give us a value between 0 and 7. Less than no 8s, now we're looking at -1 copies of 8 plus some amount. At -1, the remainder is 7. At -2, the remainder is 6, and so forth. So these two equations are telling us how many whole 8s are there in -5, and what is the remainder? What more is there in -5 besides those -1 copies of 8? So 17 is 2 copies of 8 plus 1 more. That 2 is the integer division 17 div 8. 17 is 2 whole copies of 8 plus 1 more. The 1 is the remainder. And when we do this mod function, 17 mod 8 gives us that remainder. Well, let's test our understanding. So without touching the applet, choose integer values for a and m with m greater than 0. Oops, I didn't need to do that. Let's try a equals 23 and m equals 7. Now we're going to make some predictions. What will the rest of this diagram, what will the applet show us when I make those changes? If I replace a with 23 and m with 7, what's going to happen? One question, if I want to know what is 23 div 7, that'll be the number of whole 7s in 23. 3 times 7 is 21, so I'm expecting 23 div 7 to be 3. That's 3 whole 7s in 23, and the remainder would be 23 mod 7. 3 whole 7s is 21. I need 2 more to get to 23. So I'm expecting 3 and 2 as the answers provided by the applet. So the inputs are 23 and 7. And sure enough, the outputs are 3 and 2. We can see we're in zone 3. We've got 3 whole 7s. That was 21. And 2 more. Now I'd like to transition to the second applet, which really focuses on just the mod function, not mod and div both. So the idea here is we're going to take our number line and wrap it around a circle to make a clock. So the blue buttons here control the greatest label, which is the right end. So for example, we see currently the numbers listed. If I scroll this up a little bit, the numbers shown around the clock go from 0 to 13. I can make it go past 13 by adding 1, or I could add 5 if I'm impatient. Or I can take away some of those labels if we'd like it to be shorter. And this is adjusting the right end. If I want to adjust the left end instead, I could use the green buttons. So this will increase the left end number or decrease the left end number. And if you press the square button, that'll zero out either or both of those numbers. So basically what we have here is a number line. In this case, it's showing the numbers 0 through 13 wrapped around a circle. And we might want to extend that past 13. We can use the blue buttons. Excuse me. The blue buttons control the upper limit. So we can add 5 to that, go by 5s or whatever. Where are we? 28, 29, 30. That looks nice. And the lower limit is controlled in green. If we increase it, it goes from 0 to 5. So we actually get fewer numbers in there. We can subtract 5, so counting down by 5s. These other sliders over here are just to help us make the labels readable, because depending on the modulus, sometimes the labels start getting too cramped. So this spiral number lets us control how tightly wound that spiral is, and label radius pulls them in toward the middle or pushes them out from the middle. And then the modulus itself, if we try a different number besides 12, 12 is chosen just because that's typical on a clock, right? But if we bring this down to say 7, this groups all of the numbers into 7 piles. If I loosen up the spiral a little bit, let's make the radius a bit bigger. Can we scoot this? Yeah, we can. So you can see here's 0, 1, 2, 3, 4, 5, 6, and so on. So we're just counting around. Okay, Let's see what tasks I had for you in this one. Choose an integer from 2 to 20. Well, what did I, oops, I just zoomed again. Let me reset this. Boop, and set this to 7. Okay, so I chose 7 as my modulus. Let's go up a bit and down a bit. So we've got plenty of numbers to work with. Let's loosen up the labels. Yeah, that's pretty good. Okay, so I'm going with a modulus of 7. That's why I've got 7 spokes on the wheel, 7-hour clock, 7 sets of numbers. So I'll put 7 here. Pick any hour on the clock applet. I'll pick 3 o'clock, which is here. So I see -4, 3, 10, and so on. I'll just put those numbers here. -4, 3, 10, 17, 24. Basically, I started at some number, in this case, -4 or 3, whatever number you like, and I'm counting up and down by sevens. Well, counting up by sevens the way I listed them. So if I wanted to keep it going, I would expect the next number would be 7 more than 24, which is 31. And if I was counting backwards, I'd expect the previous number to be 7 less than -4, which would be -11. So I would expect to see those numbers. Let's just check. Can I get -11 and 31 to show up here? So I'll extend the upper loop, and we see 31 shows up. And if we extend the lower, there's -11. Right, so this is just an arithmetic sequence. Start at any one of these numbers you like, add or subtract 7 to come up with subsequent and previous numbers. All right. I'm supposed to use each of those numbers, that's from -11 to 31, counting by sevens. I'd like to put those in for A in the number line applet. So the modulus is 7. Well, it's easy for me to remember 3. So it's mod 7, start at 3. Oh, mod 7, start at 3. Well, all right. 3's in zone 0. It's less than 7, so it is the remainder. There's no whole 7's in 3, and the remainder is 3. The next number on that list was 10, which moves us into the same zone. But what I want to draw your attention to is that the modulus, the modulus is always 7. The remainder, that's A mod 7, is 3 again. So with 10, that remainder is 3. Keep your eye on that 3. If I make that a 17 instead, the remainder is still 3. If I make it 24, the remainder is still 3. If I count by sevens, the remainder mod 7 is not changing. And going back the other way, we had started at 3. Before that was -4, still has a remainder of 3. And before that was -11, still has a remainder of 3. Okay. So what I noticed is that they all have the same remainder, mod 3. When we're dealing with div and mod, we can either think of the number line as being broken up into several zones of equal length. The length of each zone is the modulus, and within each zone, the structure is pretty much the same. They all have that many numbers in them. They all start at a multiple of the modulus. So in this case, this one starts at 1 times 7, but every zone starts at something times 7. And they all extend up to 6 units past 7. In other words, the remainder has to be it could be 0, and it could be almost the modulus, but it can't quite be the modulus. Because if you have the modulus left over, it means you didn't use the modulus enough times. So the remainder can't be as big as the modulus. The way that same idea manifests on the circle is just the circumference is 7, the modulus. So every 7 units, you get back to where you started. That's about it. Thank you.